Hey, sixth grade. Today's April 7th. It is Tuesday. And as I mentioned yesterday, we're going to be beginning Amplify Chapter 2 today in our magnetic fields unit. Before we begin, I want to give a big shout out to the 10 students who joined our Google Hangout yesterday. So those 10 students are Amiri, Ronald, Paris, Craig, Daryl, Tyron, Lamira, Caleb, Amir, and Alea. So thank you to those 10 for showing up to our Google Hangout. As just a reminder, I sent invitations to all of you. Once a week on a Monday, we'll be meeting with your homerooms to go ahead and just check in, see how you're doing, maybe go over some material, and really just have a time for you to ask questions if you need to. So while I know the first week is hard and it's difficult on a Monday, I do expect everybody, all of sixth grade, to be there for their appropriate times next opportunity, because I will be grading you for participation next time. But for those 10 students who did show up, thank you, and I'll be sure to throw you some extra credit or something special to help you out. So thank you again. In the meantime, let's go ahead and get started. I want you to go ahead and click on your here for Amplify 2.1. It's going to bring you to this page, which is lesson 2.1, the potential for speed. We'll begin with our warm-up, so click on that. We'll bring it down here. And for your warm-up today, you're going to be using the magnetic field sim. The directions are really clear, and they're right here for you. Just go ahead and set up a couple magnets to repel, run it, and then go ahead and watch the energy graph on the top right. So you'll follow those directions. When you're watching the energy graph, go ahead and think about what's happening as the magnets are pushed away. When the magnets start moving is the amount of potential, kinetic, or thermal energy going down, and the amount of kinetic, potential, or thermal energy going up. So watch the relationship. So go ahead and run the simulation, and then fill out this box according to what you observe, okay? So watch what happens to both all those energy levels and tell me what you observe. Take about 5 minutes. Go ahead and pause the video here and come back to me when you're done filling this box out. Okay, by now you should have used the simulation to watch the relationship between different kinds of energy. You may be wondering why we're talking about energy. It's a great question, and let me tell you a little bit more about that. So we already did our warm-up. Today's lesson, we have a new message from our Dr. Taylor Shapiro at the lead spacecraft scientist and our spacecraft launch team. So she says, great job evaluating the magnetic field line diagrams. Thank you to the previous analysis of magnetic field line data. We now know the launcher was correctly aligned in all 3 tests. What else could have caused the model spacecraft to move at very different speeds when the magnets repelled? Could the launcher have given the spacecraft extra energy in Wednesday's launch? And to figure this out, we first need to understand where the energy to launch the spacecraft came from. We will send more data as soon as we have it. Keep up the thoughtful work. So our Chapter 2 question, we have a new question today. It is, where did the energy to launch the model spacecraft come from? So as we look at these launches, where is the energy coming from in order to send this spacecraft up into space? What is energy? Just a reminder, I know we've talked about it before in other units, but it's the ability to make things move or change. So anytime something is moving or changing, I want you to think about like a football thrown through the air. It has energy. It's moving from one person's hand to a receiver. If you kick a soccer ball, it's going to move with energy across the grass. And so energy is the ability to make things move or change. Our investigation question has to do with energy. It's how can magnets cause objects to have kinetic energy? So how can magnets cause objects to have kinetic energy? And I know kinetic energy is something we've talked a little bit about, but I'm going to tell you that definition as well. It is the energy something has because it is moving. So for example, this picture here has a young child sliding down the slides, or 3 different kids. So what's causing these kids to slide down the slide is the kinetic energy they have, right? As they're going down the slide, they're actually increasing kinetic energy because they're moving faster and faster. So it's the energy something has because it is moving. Okay, so it has to do with movement. Today's lesson is actually another reading lesson, but it's a bit different, and so I want to tell you why. Here on Amplify, you're going to find that reading lesson on tab 2, so click that, and then click on the second circle. So you are going to pick one sport to go ahead and read and annotate. So you have 4 options. You got snowboarding, you got skydiving, you got trampoline gymnastics, or power balking, which is sprinting on stilts. which is something you may or may not have heard of. So pick one that you're interested in. Here are some guidelines that you can use for reading, so annotating, things like that. But to go ahead and show you, when you click on this article, it's going to come up and load. So this first paragraph is very general. Got a picture of somebody power walking. And I'm going to read it for you real quick. And I'm going to practice that active reading that you should be doing as well. So can you fly through the air? Can you zoom down a snowy mountain at 80 kilometers per hour? That's 50 miles per hour. With a little extra equipment and some practice, you probably can. Extreme sports allow us to do exhilarating things our bodies can't do on their own. To get the speed and height like we like so much, these sports rely on two kinds of energy. There's kinetic energy, which is the energy of motion, and potential energy, which is stored energy. Now, when I think about this is definitely something important, so I'm going to highlight it. I may add a note, just so I can remember there are two kinds of energy. And just remember, I do see your annotations, and so if I see your article isn't annotated, that definitely hurts me a little bit because I want you to do that. It's really helpful, and for you, especially when you have the questions you're going to answer later, this is how you find those questions. So by adding a force to the mix, these two types of energy can be converted back and forth. Motion energy can become stored energy. Stored energy can become motion energy. For extreme athletes, the conversation usually means speed, height, or both. So to learn more about how energy and force makes these exciting things possible, read one of the chapters that follows. So again, you're just reading one. All of those chapters are down here. So I'll move my head. If you come down here, you're going to find the next button. So the first one option is snowboarding. You can read that. Or you could read about skydiving. Or you can read about trampoline gymnastics. Or the last option, like I said, is power walking. So again, sprinting with stilts. And that's another option as well. So what I want you to do is you're going to pause the video just in a minute. And you're going to read one of those articles. So again, you got 4 choices. Before you begin, I want you to go ahead and tell me what sport are you going to read. So click 1 so I know which one you're going to be reading and I can look for those annotations. And as you're reading that article, just remember that there are questions for you to fill out. So underneath this page, reading questions for April 7th, just some general questions about what you're reading to help you better understand the point of this article. So again, take about 10 minutes, maybe 15 minutes, actually a little longer, to pause me and read one article, tell me which one, and answer these questions. Okay? So go ahead and pause me, pick your article, read it, and then answer questions. And when you're done, go ahead and hit play so I know you're finished. All right, cool. So by now, you should have told me which article you were picking. So you could have picked any 4, just the one though, you're picking one. And you would have filled out those questions for me down here. So again, there's those questions for you to answer as you're working. So if you have both of those done, what's great is we're actually pretty much towards the end of our lesson. We're going to go to tab 4 for the homework. And for the homework, we're going to use a different sim today. It's a little different. It's called the Harnessing Human Energy Simulation. So again, it's going to ask you to take a screenshot, which is critical shift, and then the box on the top of your Chromebooks for iPads, home button and the sleep button at the same time. And you're going to upload it to here. And then you're going to answer these questions. And I definitely care a lot about these, so please put some care and thought into it. But what parts of system store potential energy? What parts of the system use kinetic energy? What's cool is this simulation is very different in terms of you haven't used it before. You're going to go ahead and drag up different kinds of equipment. So be engineers here and build yourself something cool. So for example, I might say, I want to use a solar panel. Oopsie. Oh, not that. I meant sun. I'll connect a solar panel to it. Maybe I'm going to add, let's say, a motor. So different kinds of options for you to drag, and then you're going to run and analyze. And so you're going to watch what happens to the energy. All the directions are here for you, so please follow the directions and just answer these few questions with the screenshot. When you're done with that, you're going to finish your exit ticket. So what I advise you to do right now is just go ahead and pause me, do your homework. It takes about 10 minutes, and then hit play when you're done. So you should have finished your homework by now, which is great. And the last thing, as always, is just your exit ticket. So right here, link for the exit ticket. So the 4 pieces to be turned in for the day, just so you know when it's due, is your warm-up, your pre-reading question, plus the reading actual questions here. At the bottom, your homework, and your exit ticket. So if you can answer those 4 things for me, you're good to go. I'll see you back here for Wednesday, lesson 2.2. Please reach out with any questions. I love hearing from you all, whether it's just you checking in or actually asking for help. And I'm here to do exactly that, which is help you out. So have a good rest of your day. I'll see you back here tomorrow for Wednesday's lesson.